Hello, everyone. Suppose that you have the following production function, right? It's a Cobb-Douglas production function where YT refers to GDP, KT refers to capital stock, and NT is labor. And somebody's asking you, show that the exponent alpha represents the income share of capital stock, and the exponent 1 minus alpha represents the income share of labor. By the way, if you are one of my students in Econ 13310, this is the first question in PSET number 1. Let's start with a hint. So in the PSET, I'm telling you, the suggestion is that you start with the maximization problem that the firm faces, which is maximize profits. No? So you know that we use pi to denote profits, and as in any other maximization problem, you will start taking first order conditions. The objective function is the regular profits function for any firm, total revenue minus total cost. In particular, total revenue comes from all the income that you receive from selling the product. No? So suppose that the product that this firm produces is in particular determined by the production function, right? So in this case, GDP, and we're going to assume that prices are equal to 1. So let's start with that part. In particular, you have the GDP is determined by the production function as follows. And then you're going to subtract the total cost. What is the total cost? Well, is what you pay. I'm going to use the same order that I have in the factors of production. Is what you pay to rent capital stock and what you pay to workers. And now, as we said, let's take first order conditions. The first order condition has to be clearly the partial derivative of the profits function with respect to capital. And this must be equal to 0. All right. So this is easy peasy, must be alpha KT alpha minus 1 NT 1 minus alpha. Then the third component is RTKT. So the derivative has to be just RT. And we don't have KT in the third component. So the derivative is 0. It has to be the case that this is equal to 0. And the second first order condition is also a partial derivative of the profits function, but this time with respect to labor, and this must be equal to 0 according to the first order conditions. So the partial derivative is 1 minus alpha KT alpha NT negative alpha. In the second element of the profits function, we don't have labor, so the derivative is 0. And in the third component, we have labor, so the derivative is WT. I'm going to call the first order condition the equation number 1, and the second first order condition the equation number 2. And what I'm going to say is from the equation number 1, we could add on both sides of the equality RT, and what we will get is alpha KT alpha minus 1 NT 1 minus alpha. And this is equal to RT, right? So the only thing that I did is that I added on both sides of the equality RT. And the trick here is to multiply on both sides of the equality by KT, right? So that's gonna be the trick. So if you do that, And I'm gonna explicitly read here in green. What you will get on the left-hand side is that the exponent of this kt is 1, right? You have the same base, which is kt. So you can add the exponents in the following way. So the right-hand side is just RT kt. And you know that this guy is GDP, right? So it's very simple because now you could re-express your first order condition as alpha yt equals to RT kt. And the last step is clearly just to solve for alpha by dividing both sides of the equality by yt. And this is precisely what you wanted to show, right? That alpha is the income share of capital. So what does that mean? Basically, it means that the product that is due to capital has a participation or a share of the total product, which in particular is alpha. No? Now, the case of 1 minus alpha is completely analogous. So what you will say is that this time from equation number 2, what we have, and I'm gonna scroll up a little bit so you can see, is that the first order condition was 1 minus alpha, kt alpha, nt negative alpha equal to wt. So what I did is that I added on both sides of the equality wt. So what I'm gonna do next is to multiply on both sides of the equality by nt. And I will have everything unaffected, right? Because I'm basically multiplying by number 1, same as I did before. So now the left-hand side will simplify as follows. It will be 1 minus alpha, kt alpha, nt, 1 minus alpha. This is equal to w nt. Once again, you just need to see that this is equal to yt. So that's GDP. We know that GDP is determined by the production function, which is Cobb-Douglas. So you can simplify this by saying that 1 minus alpha times GDP is equal to wages times the number of workers that you have in the economy. And once again, what we are concluding here is that when you obtain this numerator is or represents the remuneration to workers, right? So all the value of the production that is due to labor. And in the denominator, you have the product. So once you divide the value of the production that is to the labor by the product, you will get the income share of labor, which in this case is 1 minus alpha. All right, and that's it. That's basically what I was asking you to do in question 1 of precept number 1.